Top one is what? Tangent. Second one? Sine. Third one? Cotangent. Fourth one? Secant squared. Fifth one? What goes in the blank on the fifth one? Think about number 4. Cotangent squared. Cotangent squared. Okay? All right. 1 plus tangent squared is, those are a couple we got to work on. 1 plus tangent squared is secant squared. 1 plus cotangent squared is cosecant squared. Those come from sine squared plus cosine squared equals 1. I showed you on Thursday, sine squared plus cosine squared equals 1. You divide everything by sine squared or divide everything by cosine squared to get it. But it's probably going to be better just to go through a memorize. Okay, so we had this cheat sheet. Who was not here and didn't get a cheat sheet? Okay, so if you go to the second page of that cheat sheet, we highlighted a series of okay, so here's your reciprocal identities. Okay, we're pretty good with those, I think. All right, so those we should know without much fuss, without much having to memorize. Okay, the tangent is sine over cosine, cotangent is cosine over sine. Okay, I think we're pretty good with those probably, but we've got to know those. Okay, these down here, I want to focus on those here just for a few minutes. These down here come into play a lot in the problems we're going to be doing. Okay, so we need to know not only sine squared plus cosine squared equals 1, but we need to know the rearrangements of that. We need to know that 1 minus sine squared is cosine squared, or 1 minus cosine squared is sine squared. So if we subtract and move these around, we need to know those. Okay, these other two that we just talked about, we need to know those. Now, I think it's best just to memorize them. You can, like I was showing you the other day, you can get them by just dividing everything here. This first one we can get by dividing everything by a cosine squared. If I divide everything by a cosine squared like this, look what I get. I get a tangent squared plus a 1 equals a secant squared. 1 over cosine squared would be a secant squared. Okay, so I can get that one. Or I can divide everything by sine squared. Divide everything by sine squared, I get this one. Divide by sine squared, I get 1 plus cotangent squared equals cosecant squared. So you can always get them from sine squared plus cosine squared equals 1. Okay, if you can't remember. Once you have them, you have to know the different rearrangements. So we can subtract 1 from each side, and secant squared minus 1 would be tangent squared. Cosecant squared minus 1 would be cotangent squared. Now, the one I didn't put up here is that secant squared minus tangent squared would equal what? 1. And cosecant squared minus cotangent squared would also equal 1. Okay? All right, now, another little bit of algebra here. Let's continue with these. These are called the Pythagorean identities because they come from Pythagorean theorem in the unit circle. X squared plus y squared equals 1. It's a circle. It's a right triangle. X squared plus y squared equals 1. The x is the cosine, the y is the sine. So that's why that comes to be. But let's talk about this a little bit. Here's some other algebra we're going to do. 1 minus sine squared. Guess what? That factors into 1 plus sine, 1 minus sine. So all of those Pythagorean ones, we just had over here, we had secant squared minus tangent squared. That's going to factor into secant plus 1 plus tangent and secant minus tangent, right? I mean, those are going to come up. So we were talking about factoring and canceling the other day. Those are going to come into play. Here's another thing that's going to come into play. You're going to get a problem where you're going to see sine squared minus 1. Well, that's not the same as 1 minus sine squared. But remember when we talked about taking out a negative? What happens when you take out a negative? What happens to this? Negative. This becomes positive. Doesn't that flip those around? If you have sine squared minus 1, you can take out a negative and turn it into 1 minus sine squared, which then, of course, what's 1 minus sine squared? Cosine squared, right? So these are the little algebra tricks and the little things that are going to come up with these Pythagorean identities. Now we can see it here. If I take sine squared, if I subtract the 1, and then move the cosine squared over to this side, we can see sine squared minus 1 is equal to negative cosine squared. Okay, just the way I just showed it there. But think about that taking out a negative sometimes as well. Okay, then we have these cofunctions. Now these aren't going to show up a lot, but they're going to show up a little. Okay, now what order do these have to be because of that minus? It's the same thing I was just talking about with the taking out a negative. Usually the normal way is we want, think of it as complementary. The word cofunction, co comes from complement. They add up to 90. So you remember from geometry, if you have an angle 30, its complement is 60. So if you have an angle x, its complement is 90 minus x. And so that's why the pi halves is first. It's 90 minus x. That's its complement. Sine goes with cosine. Tangent goes with cotangent. Secant goes with cosecant. Co-functions. They're partnered differently here than they are with the reciprocal ones. So that's important to understand that. Okay? Then the last set was the even odd ones. Okay? And these are going to be important ones to know because we don't want to leave our answers with a negative x on the inside. We're going to want to get that out of there. Well, if it's an odd function, basically that negative can just come to the outside. If it's an even function, basically the negative on the inside can just disappear. Because with even functions, opposites in, you get equal answers out. With odd functions, opposites in, you get opposites out. Okay, so sine and its partner, tangent and its partner are odd functions. Cosine is the only one that's an even function, cosine and its partner. Okay, now think about this page combined with this page. I could have sine of x minus pi halves, and I could recognize that, hey, that's that 90 minus x thing, but it's backwards. So how could I make that flip around? I could take out a negative, and so I would have this. But what did we just say? Sine of a negative on the inside. What happens? That negative can come to the outside. So this negative can come to the outside. And so now I have this. But wait a minute. What is sine of pi halves minus x? Cosine of x. So this whole thing can just end up simplifying down to that. Okay? These are the kind of little ways that we will use these different identities here, okay, with each other as we simplify these problems. Okay? All right. So that's some stuff to add on to what we talked about last time. Now let's talk about your homework. Okay? Any questions, concerns you want to talk about of those odd problems there? This was page, what page was it? Any issues with any of those? Yes?
57.
Read it to me.
Cotangent of u times sine of u plus tangent of u times cosine of u.
Oh my gosh. Plus tangent times what was it? Cosine?
Yeah.
Okay, ideas here.
Turn it into sine and cosine.
Turn it into sine and cosine. Now we're going to have several strategies as we go along, and what hopefully is going to happen is you're going to get better at recognizing the problem. You're going to say, hey, I remember that one. I've done something similar. Here was a good strategy. One of the strategies is turn things into sines and cosines. So this becomes cosine over sine. Maybe I should just write it out. Cosine u over sine u times sine u plus sine u over cosine u times cosine u. What happens right here? Signs cancel. Remember, when we're multiplying fractions, we can cancel top to bottom. We don't get common denominators, not when we're multiplying or dividing. When we're dividing, we multiply by the reciprocal. We flip it. So this becomes cosine u, and here the cosines cancel, and this becomes sine u. And that's it. That does not equal 1. We can't square those. We can't turn that into cosine squared plus sine squared. That doesn't work. Okay? You can't do that. That's it. You're just done. Okay? The directions work. Now, we do have to pay attention to directions. The directions just said simplify. There's more than one correct form of each answer because it depends. Sometimes simplifying depends how far you go. It's kind of like, is 1 over square root of 3 enough? Or do you have to write it square root of 3 over 3? Those are the kind of things we'll talk about, okay, as we do these. All right. What else? Cale? 55. Sine, beta, tangent. So this one's pretty similar. Yeah. Sine, beta, that's just another Greek letter. I'm just gonna use X. I don't care about it. It doesn't matter what letter you have. Now I lost it. Sine times tangent plus what? Cosine. Okay, so again, we're going to turn the tangent into sine over cosine. So we're going to get sine x times sine x over cosine x plus cosine x. Okay, now what do we got right here? We got sine squared, because now we just multiply across. There's no canceling I can do. So I can go ahead and multiply across, and I get this. Okay? Now what? I want to add them. If we're adding or subtracting, now we need a common denominator. Now we can bow tie. Remember the bow tie process is this times this plus this times this all over this. So we could do that, but it also is just take the top bottom times cosine. That's the other thing you can do. Just take the top bottom times cosine. How many prefer that? How many prefer bow tie? It doesn't matter, okay, but I think this is pretty easy too. So we'll get into one where maybe bow tie would make more sense. So what do you got now? You got cosine squared over cosine here, right? Now we can put them together. Well, good. We got sine squared plus cosine squared. You can see how sometimes we get lazy and leave off the x's. That's fine. So you get sine squared plus cosine squared over cosine, which is 1 over cosine. Now, I think your final answer, you got to put the x back in. I'm okay with you leaving it like that. Sometimes the directions will say write it so that the answer is not a fraction. So then you would want to write it secant x, okay? But I would be okay with 1 over cosine. Sometimes the directions might be write your answer in terms of sines and cosines. Now you could argue that you'd be done here, but I think you always turn sines and cosines and then should simplify it, which means put fractions together, combine terms as best you can. So the whole thing ends up being that. Okay? All right? 51. Cosine pi halves minus x. Get your book there. Yeah, read it to me. And then what's it say? Plus? Multiply secant of x. And that's it? Okay. And the directions, are they different here? No, they're all the same on all these. Okay? So, what identity do we have here? What is cosine of pi halves minus x equal to? Sine of x. Right? Now remember, the co-functions, whenever you get a 90 minus x, a pi halves minus x, you think of the co-functions, complementary, sine and cosine, tangent, cotangent, secant, cosecant, right? They're not reciprocals. So cosine pi halves minus x is equal to sine x times secant x, okay? Well, secant x is the same as 1 over cosine x. Now we're timesing these, so we can just times the top times the bottom. We get sine over cosine. What's sine over cosine? Tangent. So the whole thing just simplifies down to tangent. Okay? 53. What is it? Read it to us. You got it? Read it. Mateno's got it.
Cosine squared y over 1 minus sine y.
Okay? This one here. Okay, so when I see the 1 minus sine y, that makes me think back to what I was talking about here. Where 1 minus sine squared is what I'd like to have. You can't just square that. That doesn't work. But 1 minus sine squared is 1 minus sine times 1 plus sine. Right? Think of x plus 2, x minus 2 gives you x squared minus 4. That's what we're looking for. 1 minus sine squared is 1 plus sine times 1 minus sine. That's the key. So what I'm looking at here is I want to get rid of that 1 minus sine. So I'm going to multiply by a 1 plus sine. Because I know that will give me 1 minus sine squared down there. And what's 1 minus sine squared? What's 1 minus sine squared? That's a cosine squared, and I got that set up here. So I'm going to multiply the top and bottom times 1 minus sine, or 1 plus sine y. Now, how would I know to do that? It's because of what I know. When I recognize this, that's just what I'm telling you. When I see 1 plus sine or I see 1 minus sine, either one of those, I'm thinking of this. Will get me to that. Okay, so I'm thinking I want to get those multiplied together. Okay? So again, the more we practice these, the more we'll recognize these things. So the top I'm just going to leave. So that's that times that. The bottom is going to be 1 minus sine squared. But what did we just say 1 minus sine squared was? Cosine squared. And now we can cancel, and our final answer is 1 plus sine 1. Okay, that's the thought process. Yes?
If you right off the bat turn cosine squared.
Okay, I got you. There you go. I like that, and we could do that on that one, and that actually might make a little more sense on this one. Although, and so I want you to see both of those options, or that make more sense. But people might have thought of that first. But I want you to understand this idea here, where you have a 1 plus sign or 1 minus sign, you multiply by the other one to get you that. But here's what Kale's saying, cosine squared, he's just going to take this cosine squared and right off the bat write it 1 minus sine squared. Right? And then this is 1 minus sine y. Good, because now what can I do with this? Factor it, right? I can factor that into 1 plus sine y, 1 minus sine y. So that's just going kind of the other direction of what I did. 1 minus sine y, cancel, cancel. Final answer 1 plus sine y. That works good too. Okay, that works good too. Usually we're going the other way, aren't we? Usually we're wanting to take 1 minus sine squared and turn it into cosine squared. But taking a cosine squared and turning it into 1 minus sine squared is beneficial here. So that's a good thought. Okay, they're both about equally the same as far as how much work, but okay, they both work well. Right? Yeah.
Can we go over 43?
What is it?
Cotangent of x over cosecant of x.
Okay, this is when you get into a lot of just flipping and inverting and multiplying and those kind of things. What I would do if I was doing this one, but there's just so many different ways to do it. But I would just probably write it as one big fraction like this. Cotangent is that. Put a great big fraction bar. This is this right here. Okay. Some people get comfortable noticing that you could just cancel those signs, but I don't like doing that because it gets too. If you start doing that, if you have fractions and fractions just start kind of randomly canceling stuff, it's not a very good idea. So what you want to do instead is you say, okay, if I'm dividing by this, that's the same as what? Timesing by the reciprocal. So you do that. And then those cancel, and then we end up with cosine like that. So that's how you want that to look. So turn that into cosines and sines, turn that into, and then invert multiply. Is, I think, the way to do that. Okay? It does work. It does work. I mean, if you have a fraction A over B, and then you got C over D like this, it does work to cancel the A's with the C's. Whatever's in these two spots, you can cancel. Whatever's in these two spots, you can cancel. Now, the problem becomes if you cancel the stuff here and here, you've still got to invert and multiply. So the final answer ends up being that, D over B. And so sometimes people get in trouble with that. So I think the better thing to do is invert this up here and then do your canceling. I think that's better. Okay. All right. Let's do a few here where I let you try some things. Let's skip that one. Let's do this one right here. Get a common denominator. I know I just gave you a big hint right there, but get a common denominator. It could be bow tie. It could be just get a common denominator, either way. Okay, so again, getting a common denominator, the advantage to that, the common denominator you can tell is going to be 1 minus cosine squared. I mean, you're going to have a 1 plus cosine and 1 minus. If you bow tie, that would just be 1 minus cosine times 1, which would be up here. And then this would be 1 plus cosine times 1, which would be up here. And you would add those together. So 1 minus cosine plus 1 plus cosine. And then your bottom is the 2 times together. You multiply those two together, it's 1 minus cosine squared. Okay, what happens on top? What happens on top?
Do the cosines cancel each other?
They do. Okay? Yeah, maybe they would have, maybe they wouldn't. It doesn't matter. I mean, it doesn't matter, but it's just nice that they do. So a lot of times that's what happens, okay? And so the cosines actually disappear, and you have 1 plus 1, which is 2. So you end up with 2 over sine squared, which would be fine to leave. A lot of times the directions say, well, matter of fact, on our homework, there's going to be a couple problems. It's going to say, we have a worksheet here, and there's various questions. One of the questions they'll ask, they'll give you an expression, and then they'll give you a second expression. They'll say, turn the first one into this. So it's kind of like you know what you want to end up with, but you still go through these same processes. Another set of problems in there says, write your answer in terms of sign. Now, in terms of sign means your answer has only signs in it, and maybe some numbers like 2 or something. So 2 over sine squared is where you'd stop if it said write it in terms of sign. Or if you want to write it like this, you can. Yes?
Why wouldn't the final answer be cosecant squared over 2? Because don't you just switch them around?
Great question. 2 over sine squared, how can I say this? What's another way of writing sine squared? 1 over cosecant squared. Would you agree with that? Forget the 2 a minute. Yeah, see what you're doing, by flipping that, you're turning that into this, actually. You get what I'm saying? And then but that's a different thing. That's like 4 and 1/4 are 2 different numbers. They're 2 different answers. So what we have here with 2 over sine squared, what we have is 2 over 1 over cosecant squared. Now invert and multiply. So you bring the cosecant squared over 1 up top, and that's why you get that. Okay? So I'm glad you asked that, though, because that is a common misconception. Sine squared is reciprocal is cosecant squared, so it can come up there. Now, let's talk about this a minute. What if this would have been 2 plus cosine over sine squared? Now, can we bring that sine squared and just flip it up there? Because of the plus sign, we really can't. Now, we could, as long as we did this, if you did the 2 plus cosine and kept it in parentheses and then brought it up, then you could do that. Okay, then you could do that. Okay, we'll do a few more and then have some more time to come back. This is what I was telling you some of the homework problems will be like, where it gives you this and then a second one, it says turn this into that. So in other words, they're just telling you what your final answer would be. So just like the one we just did, where I would give you that and say turn this into that, and then you would do the work. So the only difference is in doing it is you kind of know where you should end up. That's the only difference. Okay, go ahead and try that. Go ahead and try that. Okay, let's see what, see how far you got here. So common denominator, right, has to be your first thought. Bow tie would be cosine times cosine, be cosine squared. And then this times this, which you'd have to FOIL. Or if you just write it in the red like I did, the common denominator is this times this quantity. So I just multiply top bottom by cosine, top bottom by 1 plus sine, same thing. And then the common denominator would be this times that. So what do you get? You get cosine squared. When you FOIL this, you get 1. Outers and inners would be 2 sine x. Last times the last to be sine squared. So you end up with that on top. You end up with cosine squared plus, and then you get 1 plus 2 sine x plus sine squared x. Okay? So we want to be able to do that, those things right there. That's just getting a common denominator. It's algebra, but using the trig functions. Okay? It'd be no different than if we just had the problem in algebra class, x over 1 plus x and 1 plus x over x. Getting a common denominator, same business. Okay? Now, I put parentheses around this trinomial here, but I don't really need them because it's just adding, so I can just get rid of those parentheses and I can add, and what do you notice here? You see the cosine squared and the sine squared, right? And that's going to add up to make what? Cosine squared plus sine squared, so we're always on the lookout for that. Cosine squared plus sine squared is 1. Of course, our denominator is just that right there. Okay, so I'm just going to rearrange those. So over here, I got cosine squared plus sine squared plus 1 plus 2 sine x, so just rearrange at the top. But that and that make a 1. Plus this other one that's already there makes a 2. So the top becomes 2 plus 2 sine x. Right? So cosine squared plus sine squared makes a 1, plus that 1 makes a 2, 2 plus 2 sine x, and what can I do with that 2? Take it out, because I see this 1 plus sine sitting down here. Now you don't want to distribute, so up here on top we do want to FOIL that out, but on the bottom we do not want to times these together because we're hoping to cancel. We're hoping that things will combine up here and cancel, and we're hoping then that what's left will cancel with what's down here, and so what's on the bottom we want to leave in its factored version. So we want to leave it like this. Do not distribute that cosine, and now look what happens. Take out the 2, now you got your 1 plus sine x's that cancel. And then you end up with 2 over cosine, and which of course is 2 secant, which said that's the one he was asked about earlier. The 2 stays up there, and the cosine just flips up with its reciprocal, secant x. Okay? All right, so that's 77, what that would look like. All right, let's look at number 82. We'll just do this one together, and then we can go to work. Okay, so this one. Now, the directions on this one are a little different. The directions here say rewrite the expression so that it is not in fractional form. Rewrite it so it is not in fractional form. So anybody have a thought to start?
Take both functions and change them like sine and cosine.
Okay, that's one thought. Now, that gets a fraction inside of a fraction. I actually did that as I was working it here this morning before school. I was trying to find some problems here, and that's what I did first. Now, it's longer that way. And after doing it, I thought, oh, that was silly. There was a faster way. Now, you're not always going to take the fastest way. What's important is you get there. So it doesn't matter. So the problem with sine and cosines is you get fraction in a fraction, and that can be messier, but sometimes we can't avoid that, so we can do that. Okay, just because of time, I'm going to go the little shorter version. Here's the other one you might think of. When you see, does anybody see it? And I'm thinking of the tangent and the secant together. What's the one that on your identities that's got tangent and secant together? Tangent squared plus 1 equals secant squared. Let's go back to our sheet here. So right back here, remember this one right here? Secant squared minus tangent squared is 1. That's just a rearrangement of this one. Okay? Or, flip that around, tangent squared minus secant squared would equal what? Tangent squared minus secant squared would be -1. If I subtract the secant squared to this side, tangent squared minus secant squared, I have to move the 1 over here, that'd be -1. Or just flip this, factor out a negative, it'd be the opposite, -1. Now, and what do I know about secant squared minus tangent squared? That could be secant plus tangent, secant minus tangent, right? So that would be my thought. Here I have it right here. Secant squared minus tangent squared, secant plus tangent, secant minus tangent. So knowing that, and that's why getting used to those and knowing those, that makes me think of, you know what I'm going to do? I'm going to multiply this right here. Now, I like if I want to stay away from the negative, I like this one. Secant squared minus tangent squared is 1, so I'd rather do the secant plus tangent and the secant minus tangent. So I'm going to think of this one as, I'm going to think of this as secant plus tangent, okay, instead. And so I'm going to multiply by secant minus tangent, okay, top and bottom. Okay, so here we go, secant x minus tangent x, top and bottom. I could have done tangent minus secant, but then it would have been negative. It doesn't really matter. Okay, so on the bottom here, now I just got it saying is, I don't want to FOIL out the bottom because I'm hoping things cancel. Well, that's actually not my goal on this one. My goal on this one is to write this as secant squared minus tangent squared. Because what did we just say that equaled? What's secant squared minus tangent squared? 1, right? So that was my goal. So now look what I have on top. I have 5. I can go ahead and distribute. Here it would be okay to distribute. It'd actually be okay not to distribute. Doesn't matter. But we end up with that. And then the bottom here is just 1. So we get 5 secant x minus 5 tangent x. That's my final answer. Okay? Because the bottom is just 1. So again, it's a recognition. We got a lot of different ones going on there. It's just practice and repetition that helps you to see what to do. Okay? All right. So for tomorrow, we're going to do just the front side of this worksheet here. Just the front side, please. It's got several different sets of directions. So go ahead and use your cheat sheets. But try gradually over the next couple days to wean yourself off of having to look at the cheat sheet. We're probably going to do a short little 10-point quiz on on Wednesday. A little longer quiz on these on Thursday is kind of the idea. Okay? So we'll have some more practice on these tomorrow for sure. So first 3, it says convert the first into the second. So that's like the one we did a minute ago. Okay, so you take the first one before the comma, and you're going to try to turn it into the second one. You can do your work kind of on that line. You got to write pretty small probably. If you want to do it on separate paper, I'm okay with that. You can just do that, it's fine. Then it says write each in terms of signs. So you want to turn those into sines and cosines. Hopefully the cosines maybe cancel, and you end up with just signs. And then likewise the next group in terms of cosine, next group in terms of tangent, and then just follow the directions. The very bottom ones, it says express each identity in 2 equivalent forms. So that's just rearrange them in 2 equivalent forms like we were just doing there. Tangent squared plus 1 equals secant squared minus tangent squared equals 1. 1 minus secant squared equals tangent squared, whatever, right? That kind of thing. All right.